All right, ladies and gentlemen, hope you're all fresh and awake for this session, 4 p.m. Central European Time. Welcome to a new scenario webinar together with our partner, Arc Engineering. And as you can tell from the title already, today it's really all about cost engineering in the age of real-time automation. Let's maybe start with some of the intricacies in the cost engineering landscape and maybe some of the difficulties that we see in today's fast-moving engineering and manufacturing landscape, which really, to be honest, cost engineers find themselves at the forefront of decision-making processes that heavily influence product development and pricing. The complexities faced by organizations span a wide spectrum, going from the intricacies of pricing single components or even multiple components to even aligning with sustainability objectives such as adhering to stringent CO2 emission standards or other regulations made by the government. Cost engineers like yourself are tasked with determining the most cost-effective solution, which is really a challenge, especially with fluctuating production volumes. Despite the significance, the processes governing cost estimations in engineering frequently fall short, resulting in suboptimal decisions and operational inefficiencies that ripple not only across departments, but even across the entire organization. The status quo looks more like cost engineers relying upon a mix of disparate tools, including spreadsheets, custom software solutions, API integrations with various web services, and specialized databases. So really, it's much more trying to amalgamate various tools instead of having a one simple solution that facilitate that process. That begs the question, what is the solution? And for us, for me and Heinrich, who joined us in today's session, it's really straightforward. We use a universal language that kind of unifies all tools and information sources relevant to cost engineering. This language would encompass various dimensions, including geometry, lifecycle metadata, spreadsheet data, various databases, CO2 values, or other KPIs. And for that reason, as I already alluded to, I'm very happy to welcome Heinrich Schmidt from Arc Engineering, and who is a digitalization consultant at Arc and consulting in design and development automation. He also supports the application of Synera in-house, develops workflows, and is heavily involved in the programming of tools, one of them being cost engineering. And one thing that's probably also important to know before I hand over to Heinrich is that he's not a cost engineer by training. So he demonstrates in a couple of minutes how he was enabled to use a tool like Synera to calculate cost engineering processes or kind of facilitate cost engineering processes. Quickly about myself, my name is Yusuf Murat, host and moderator of today's session. My background is in FEA, computational fluid dynamics, and AI. And with that, I'm now going to hand over to Heinrich.
Okay, hi there. So let me quickly share my monitor. Let's talk about the challenges of cost and engineering. As I view the whole topic, there are two big domains, engineering and costing. Each for itself is super complex. Many different processes, many different tools, and they have to interact with each other and then also interact with between each other, between the two domains, between engineering and costing. And so let's take first a look into engineering. Engineering would consist, for example, so we start with a design, a styling, CAD data. This has to be forwarded to the CAD guys. The CAD guys will create geometry out of it. But also they have to feed a PDM system, probably also retrieve old parts from a former project and just refactor them for a new project and use standard parts. And at some point they will say, okay, this part is all right, but is it functional? Then they have to forward it to the CAE department, make some FEM simulations. And they also use another database where they probably have some material data or some standard sets for test procedures. And if they're done, they're forwarding the information back to the CAD guy, and he will figure out my part wasn't good enough. And so they repeat the whole process, but eventually at some point, we will retrieve some geometry where we say, hey, this is all right. I now need to know how much it costed. And then we enter the world of cost engineering, and they have a similar set of tools. Probably they use a tool like Factin, which could calculate the part cost, and Factin also uses some kind of database where they retrieve data from. probably some materials, some suppliers they have. But probably they also retrieve the data, hey, which suppliers do I have to get the part out of? They get it from SAP. And they also have a database. And then eventually those two fractions will create some cost, put it into an Excel list and forward it back to us engineers in form of numbers. And then we figure out, hey, that part is too expensive. We have to restart the whole process. So what are the challenges here or the problems we identify there? The one thing is it's super fragmented. It's so many tools, so many different teams, and it's a mess. So many tools to have an overview of everything is super complicated, and not everybody could actually access the different tools and informations. Also, it's super individual. I think everybody of you has their very own complex processes and tools and a different infrastructure. So you can't make a solution that fits everybody. So it will be always super individual. Then the knowledge is not every time kind of conserved in a tool. Most of the times it's the knowledge of an expert or the experience of an expert, and you have to retrieve it, have to talk with them, and then you get your information, your cost. And then in the end, it's super repetitive and linear. You have to do everything again and again in the same project for the next project. And it's getting kind of cumbersome and boring or exhausting to do it every time. So what are the solutions for that? So first look at the fragmentation. By connecting all the tools on one platform, for example, Sonera could do that with a seamless integration of all the tools in one platform. It's not that fragmented anymore. But a certain level of fragmentation is all right. Since everybody has an individual process, it makes sense to kind of summarize different fragments to modules, which would fit a great base of many users, and they could create their own whole cost engineering process with the different modules. Then the knowledge could be conserved with a low code algorithm, and low code is like the easiest gateway to create an algorithm. It's more comprehensible than written code like in Python or C# or whatever. And so it's easy to implement it. And the same is for the repetitive and linear tasks. Translate them into algorithms with visual programming, and you have solved that. But what would be the steps to create such a workflow? So my first step personally is I first identify the steps. Which processes do I want to interchain? So for example, here I load cut data, then I re-evaluate the part, then I calculate the cost. Tip for that step, make it first with pen and paper. That's the fastest way still. And if you're confident, okay, this is a good process, then go to the next step. Identify the different interfaces and formats. So what tools do we really use? In that case, a PDM system, Sonera, and Facton as a cost calculation tool. And how do they communicate with each other? The PDM system will retrieve some 3D geometry in a parasolid format, or it could be a CATIA cut bar, and we'll forward it to Sonera or just load it into Sonera. And Sonera will drag out the information I really need for the costing tool in form of a JSON file or a dictionary, like the wall thickness, the weight, the projected area. And then Facton will retrieve us the real cost we have there. Small tips here, if you're using third-party software, check out the templates within Sonera for web and API. How could I integrate a web application database into my Sonera workflow? The second part is get off this third-party software the API documentation. And then you should already be capable to implement it into your workflow. Then the third part, obviously, at some point, I really have to do stuff in Sonara. So build your module. For that, I would really create modules optically in Sonara. That's my fourth tip. Establish a clean and uniform structure within Sonara. This keeps things comprehensible and also modular, since you have a designated in and an output, like you see here at the top. And the last step is obviously testing. So you have to run it again and again, and not just by yourself. That's the fifth tip. Give it into other hands. Gain another perspective on the topic. Is it usable? Does everybody comprehend what you did in your workflow? If so, then you got a great tool and you could use it in your projects. So how would it look like in Sonara itself? So I have two different scenarios here. First thing would be, okay, I just want to get cost calculations I already had done. So, and first I'm using for that Facton. Obviously, this is a tool where you have to pay for. So there will be some kind of login in the beginning. So I have here a login add-in for Sonara where I will retrieve my calculation IDs. So this is a list of all the calculations I've already ran on Facton, and also I get my token. This is kind of a key which enables me to use the tool. Then I could either get a single ID where I want to see the cost, or I want to see all the calculation I've done. And then in the end, with the get cost add-in, I would receive my cost fractured into production, material, manufacturing cost by one, machine cost, and labor cost. And in this scenario, it's just one calculation, but I could also change the input to a list. And then I would get both calculations I could see in the beginning. This is a neat feature, especially if I don't know which calculation I really need.
Yeah, maybe one question, Heinrich, in between. I think the question would come up in terms of the input. What kind of input formats can you use when we talk about input? What data types are we talking about?
Whatever the tool needs. As I mentioned in the beginning, how I would set up a workflow. We have to clarify the formats. And so far, Sonara was capable of creating each format I used. For example, for each web application, I used the dictionary format and reformed it to a JSON file. This is a standard format that nearly every tool could read. Yeah. So I will always try to keep it as standardized as possible.
That makes a lot of sense. Have you used any other tools apart from Facton?
For costing, not, but I used, like I mentioned before, the different templates Sonara offers. Yeah. I implemented OpenAI topics like ChatGPT and also DALL-E, and it worked fine. So I'm quite confident to use it more often in the future.
Excellent.
So, okay, then jump to the biggest scenario. How do we connect engineering and costing in that instance? So first, as I mentioned, we have to retrieve the cut data. Sorry for that one. So I choose here my cut part. So I already loaded one. So I want to change the part. And then I will receive out of my PDM system, on the one hand, the real geometry, and the other one, some meta information. Hey, which material is this part, which manufacturing process? And then I forward it to the next step where this is more refined. I will just extract this information of the part metadata, which I really need for the cost calculation. And then we really enter the cost calculation part. This is another small info factor where we really could set up a calculation. So we want to create a new cost calculation. So we switch the toggle to on, and Facton is running in the background, and we'll create a new cost calculation. This will take half a minute, I think. Right now we're working on the speed, but eventually we receive the cost, and it's still way faster than writing an email to your cost engineer and getting the information back. And so, as mentioned before, we receive then the ID of the cost calculation. Then we have to update our database with all our cost calculations, and in the end, we receive the cost. The add-ins themselves are exactly the same you've seen in the other use case. And that's actually it. It's actually quite, easy. It doesn't look that fragmented at all. It doesn't have too many cables. I think it's still quite comprehensible.
Yeah, it looks quite neat. It looks almost too good to be true, Heinrich. So the question people might probably ask is, how reproducible is the workflow? Let's say we have like 1 or 2 use cases that you've showed in the example, but what if I have other input data, for example? So how much can I scale this process?
As big as you want. In that case, with Facton is a massive tool, and you could add there in that database your own tools. Okay, do I have just like machining parts? Do I have injection molding parts? And then you could set up different costing models for different manufacturing processes, or you could even tailor it into different suppliers. You have, okay, this supplier has this machines, this materials, and then you could create your own toggle for that. So I don't see any limitations there. You could tailor it the way you want it.
How can we debug that? Let's say we have a small feature, a small node, for example. Can we debug that? How do we find mistakes when we set up such a process? Is that easy, or is it kind of a black box, so we can't really know what's going on behind the scenes?
Both things are possible. If I'm using it in, it's in black box. I can't really bug fix it. I have to trust the people that will supply me the add-in. But if I create my own process, I could create a I could create a random set of data within Sonera. This is done within minutes, and just test them. And if they retrieve any failure, I could retrack it and see at which node the failure was, and then correct it by myself.
Yeah, that makes sense. Maybe if some people in the audience, maybe some of the attendees, if you have specific problems that you encounter on a day-to-day basis, maybe put it in the Q&A box, and then Heinrich or I could answer these questions in the meantime. But yeah, go ahead, Heinrich. Anything else that you wanted to explain?
I could just show some other things. Probably we could talk about the runtime. So if I would just add this workflow to the runtime, would be just adding this input as an input, and probably the cost as an output. Yeah, it's a text file. I make an output out of it, and then just publish it to the runtime. Then I would gain access to the runtime. I could run the cost calculation completely online without even opening Sonera, and make it accessible for people that don't really use Sonera. That's also a neat feature.
I think there was kind of a little spoiler towards the end of the webinar. So what we will share at the end is kind of a link, exactly what Heinrich uses at the moment, where you can try either part number 1 or 2. So I'll share the link in a bit in the chat, so you can also give it a try after the webinar. But it's really exciting to play around with and just see what are the manufacturing costs, what are the machine costs for a specific part. All right. In terms of building the workflow, we got a question there. In terms of building the workflow from scratch, how much time did it take you, Heinrich? Because as I've mentioned in the beginning, you are not a trained engineer, right? A cost engineer. How much time did it take you to build that from scratch?
So this version is a more refined one, since we created like a real add-in. So Yeah, I have really like factor and basic containers. This takes a bit more time. It was like 1.5 weeks, 2 weeks to create them. But before that, I had like a simpler solution where I just used the web nodes from Scenario. This took me around 2 days. And I think that was an all right invest since I also implemented it. It was even more. There was also a tooling cost and a CO2 footprint within those 2 days. But I would still prefer the solution with the real add-ins since I could make them easier accessible for my colleagues.
Yeah, I think 2 days doesn't sound too bad. Do you have any reference in terms of time-consuming processes? Also, maybe a KPI like X% of time saved when you compare it to processes or tools that you've used before. Do you have a concrete number?
It always depends on the cost engineer I had. So on their response time, but it could be usually a week till I get one proper cost estimation. Could be 2 weeks, could also be just a few days.
Mm-hmm.
But it's just one set of information I would forward to the cost engineer. But now I'm unable to make the cost calculations by myself, and I don't have to wait for a response. I could calculate, I think, 1,000 variants of my part and have information. Don't have to forward 1,000 variants of my part to the cost engineer. And that's something I really, really like.
Yeah, doing it yourself, I think, is a crucial point because it goes back to the topic of capturing knowledge. How do you think it's perceived in the industry of actually being able to capture knowledge in a tool like Sonera? Do you think there's a bit of pushback because, well, I'm giving all my knowledge that I've acquired over the years into kind of a low-code tool?
It's always a bit of a philosophical question there.
Mm.
So often experts are afraid that it will be replaced by an algorithm. But I have a different perspective on that one since I've been in an expert role by myself, and I always had like the feeling of pressure on my shoulders that all the knowledge is on me. And if I'm not there to give my knowledge back, or if people have questions, I need to be there. They can't do them by themselves. And oh, feel reward if I could enable somebody else to have the knowledge or to use my knowledge. And with things like a low-code platform, I'm enabled to conserve my knowledge into an algorithm, enable other people to do my job, and probably I gain time with that process to work on my processes, on my methods, to be better, to refine them. And I think that should be the mindset, not being afraid that I'll be replaced.
Definitely. I think if you get rid of, let's say, 70 or 80% of your tedious tasks, there will still be a manager coming around the corner telling you, hey, we have other tasks on your list, so just work on those. But I think it's more about getting rid of the tedious and mundane ones rather than, hey, I'm going to be substituted, which is probably not the case.
Absolutely agree on that one.
Basically, does this work for complex assemblies?
I think it will, since it could use list features. So you could, on the one hand, calculate first the cost of every single part and get it into a list. And then it's about the manufacturing. Okay, do I assemble it by hand or with an automated process? Then we have to get somehow into a tooling cost for that automated process. We probably need some robots or anything. That would cost money. I think the tooling part is rather complicated since it's very individual based on the assembly you have. But I think the single part cost is rather easy. That we just give it back within our list. Yeah.
I think it makes sense. And then I think a follow-up question would have been, is Sonera choosing the manufacturing process by itself? I think what you suggest is more like you give it the manufacturing process that the engineer kind of gives as an input or parameter.
Yeah, definitely. If you implemented a process that will calculate the tooling costs for the different manufacturing processes, Sonera is capable of comparing them, obviously, and then choosing the right one. Those would be two different digits you have. That one is cheaper than the other one. So
it's kind of almost binary. Okay, with another question, what are kind of the biggest challenges that you see in the industry in cost engineering, and how can they be overcome using the low-code approach?
It's for me personally, it's a fragmentation of the tools.
Yeah.
To have an overview over each single step is rather difficult. So I like having them on one platform. And I'm also gaining the ability to get the information I usually need from other departments by myself. I'm probably not responsible for the decisions then that happened. It's still the expert or the department that's giving me that, but it gives me a better feeling of their department. Okay, how does the cost, how will the cost be calculated, or which parameter that I decide has which influence on the cost? And this is a great ability I gain with that approach.
That makes absolute sense. Thanks, Heinrich. And then I think this is going to be that you can answer perfectly. Is it mandatory to have a single source of truth for the input data?
It makes, on the one hand side, it makes sense to make it makes things comparable, so everything has the same source. But it also makes sense in different topics to compare different data sets, so different sources, which one fits better my needs. So I wouldn't decide for either one. I think both things are important.
As I promised, I'm going to share a link in the chat that you could all open right now, and that should work. So you could use as a part, maybe Heinrich, if you switch back to your browser for a second. If you open that link, ladies and gentlemen, you will be able to type in either part number 1 or 2, and then run it by yourself. And of course, if you have any questions, maybe an own use case that you want to explore using Sonera, feel free to reach us via email. I'm going to post my email in the chat so you can reach out to us if you have any more questions regarding your use case. With that, I think we have 3 minutes left. Is there anything else, maybe some closing remarks, Heinrich, from your end? How to get started?
No, I'm actually quite curious of the questions. Most of the times there's new perspectives that are super interesting. So looking forward to them.
Definitely. So please post your questions. We have some time left, so we'll give you a couple of minutes. And after the webinar, we'll obviously provide you with all the slides from Heinrich and Sonera. Myself, we'll send you also a white paper, which kind of is more of a condensed version of all the knowledge that we've shared in the session, as well as access to a 14-day trial of Sonera, where you can give it a spin yourself. Cool. Let me see. Ulrich is asking, is this a web-based solution? So you have to differentiate. I think Sonera is like a local installation, but Sonera Run can be deployed in the web. Anything else you would add here, Heinrich?
No.
I think that's
correct. It's both.
Kind of, yeah. However you want to see it. Nitesh is asking, any changes in the Facton database, for example, raw material has changed. Would this impact your Sonera calculation instantly? So basically, if I change the Facton database input, would it be a real-time change?
You just have to recalculate the login button. So if you click on run again, then it's actually, it will just renew the whole database. It's based on, but also since it's just retrieving the calculations you've already done, as long as they're already in the cloud correctly, you could retrieve them instantly. And so now,
Excellent.
Just
I think
a
that
quick
works.
update.
That summarizes it. Excellent, Heinrich. Really nice. Thank you so much for joining, by the way, in today's session. I hope there will be more sessions with us together in the future. And if you have any more questions, ladies and gentlemen, I put my email down in the chat. So if you want to reach out to me or Heinrich, I'm more than happy to forward your questions to Heinrich. And with that, we'll wrap up the session, and thank you so much for attending. Bye-bye.
See you around. Bye-bye.